Hey guys, it's Axiomatic Uncertainty here, and today we're going to be doing some simple practice using the definition of a derivative, which you can see right here, and we're going to be doing some simple practice problems which I found on the UC Davis website. So the first problem is going to be the derivative of 5x squared. Sorry, I'm so slow at writing this. Minus 3x, and I believe the last term is a 7, so there we go. So in order to solve this, we're going to need to start off by just writing out limit as, and I'm going to use h here instead of delta x because it's much faster to write, as h tends to 0 of 5, and then x plus h squared minus 3x plus h. There we go. Okay. Minus this last bit here, which is going to be plus 7. So actually that's just plus 7. Minus f of x, which would be 5x squared, sorry about this taking so long, minus 3x plus 7, okay? All divided by h. Okay, so first thing you ought to notice is that we can just split this up into 5 sections. So if I just go over each of these, the 5 sections we can split this into are this one. So this 5x squared and 5x term. These are both part of the same bit of the problem because as you can see, that's from the 5x term. And we can also get this section here. This 3x plus 4 and this 3x. And that's right there. And then this last bit, which is 7, and that is just on both of these. And actually, sorry, I need to correct one thing here, which is because this is subtracted, this needs to be a plus, and this one here, let's just, oops, draw over that, and we'll draw a minus here instead. And the reason being because this is all subtracted. And this is a negative term, and that's a positive term, so they have to be inverse. So, next bit here, or opposite. So, next bit is splitting this up and simplifying. So first we're going to simplify this first bit because it's the most complicated. So we'll go 5x squared, right, plus 2 times 5, which is 10xh, so this is just distribution, this is very simple, and 5h squared. Okay, so then we have to go over here, minus 5x squared, okay? And this is simply because this is just 5x squared over here. So we've taken each of these components into this one. We simplify, this is all over h. And now we need to cancel. So we can cancel this 5x squared and this 5x squared, and we're simply left with this. Now, you probably noticed we can cancel out the h's here. So as you can see, here we can cancel this one and just make this one a 1. And then we can also cancel that one. And so now we have equals limit as h goes to 0. Sorry, this is taking me so long. My handwriting, or whatever you call this, my mouse writing has improved quite a bit since yesterday, as you can see. It looks rudimentary at best, but it's pretty good. So 10x now is what we have on the, oh, actually, I can just write this lower because we have no denominator now. Just put parentheses here just to make it clear. This is all part of the limit. 10x plus 5, and then we have an h here. Now, you'll probably notice this bit here, this bit is just going to 0, so we can just cancel that. And this has no h values in it, so we get equals 10x as our final part for this derivative here. So this is this derivative. So we've taken care of that. Now we need to do the 3x and the 7. So we'll do the 3x first of these two. And in order to do this, we need to take this term and this term and just bring them into their own limit and simplify. So we'll bring this over here. Limit as h tends to 0 of then negative 3 x plus 4, or x plus h, so negative 3x, and then minus 3h. Okay, that's pretty simple. Now we have one bit over here, which is plus 3x. 3x. Right, all divided by h. And as you can see, if we just get our color here, we can cancel this alongside this. We can also cancel that and that. And as you can see, this limit evaluates to negative 3. Just sort of circle that. And the last bit, which is this negative 7 thing here. And let's just do that up here. It's getting a little bit disorganized, but it's fine. So let's just divide that out. And in the future, as I said yesterday, I think I may use a whiteboard because this is really slow and it doesn't have to be this way. But anyhow, we have up here a 7 and a negative 7. So 7 minus 7 divided by h. And as you can see, we can just cancel the entire numerator and we're left with 0. 0. Okay. That would be the first 3 derivatives. Sorry about that. I didn't like the way that trailed off there. That was just kind of terrible looking. So last bit here is just to write out the entire derivative. We'll do that in green. So we're going to say d. Okay, let's just write it this way. F prime. I was going to write dy dx, but for simplicity's sake, we'll write it this way. F prime of x equals, and then our derivative, 10x. 10x minus 3, and that would be our final answer. And that is that. So I hope you've enjoyed this example of doing derivatives with the actual definition of derivative. It was pretty simple stuff, but I was hoping that if you haven't done derivatives before, this would be a good introduction to using limits to solve for simple derivatives like that. In the future, we'll do some other examples maybe, and like power rule and stuff. So that's that for this video. Thanks.